right, guys, thanks for having me here. I appreciate getting invited, and I always will come talk to people. Talking is my superpower. I like to talk. In contrast to Greg, I only have about 30 slides for my 45 minutes, but I promise I'm probably going to talk more than he did. So I want to talk about the technical tools in a GCD toolbox. I want to state up front, I'm not going to talk at all about any of the other things that a groundwater district can or should be doing. I'm not going to talk about education, not going to talk about your administrative stuff, not going to talk about permitting or anything like that. Just the technical side of things. So the first thing I want to talk about is what kind of toolbox do you have? And as I was looking for pictures of toolboxes, the first one I came across was this one that looked like my granddad's toolbox with some of those, old hand tools sticking up out of the top. And I thought, oh, I'm going to put that up there and make that kind of be the counterpoint. And then I got to thinking about, my granddad could build a lot of stuff out of that toolbox. Sometimes those old toolboxes are pretty handy wielded in the right hands. Some of these toolboxes are shiny, some of them are big, some of them are small. Some of them might be empty. We don't really know. So let's talk about why we need tools. Why do we need tools to start with? And it doesn't really matter who you are or what you're doing. Let's try to play. The only reason that you really ever need tools is to build something. You may not be building a high-rise office complex on the site of an old farmer's market in Frankfurt, Germany, but you're building something. So what are you building is the first question you need to ask yourself. Are we trying to collect more data or collect better data? Are we trying to build somewhere to store that data? Are we trying to display that data so that we can better show it to the public or better use it ourselves? Are we trying to build a permitting system where we need all of these pieces of information to be in one place so that we can look at spacing or well density or something like that? Or are we trying to get some data analysis done? Maybe you have a bunch of data. A lot of districts have a lot of data. And the next step is, how are you going to use that? How are you going to analyze that? What can that data tell you? So first you need to think about, what are we trying to build? Where are we trying to go? And how do you know what to try to build? Well, what does your management plan say? That's where I always start. If you say you're going to do it in your management plan, do it. And if you're not going to do it, don't say you're going to do it in your management plan. The other thing is, what does your DFC say that you're going to achieve? Are you talking about spring flow? Are you talking about water decline? Depending on what your metric is in your DFCs and in your management plan, you need to be sure that you're collecting the correct information for that and you're able to utilize that information in a meaningful way. So, what kind of tools do you have and what kind of tools do you need? And to be absolutely clear, I'm not talking about this tool. How we're going to break it down today is hand tools, power tools, and automated factory tools. So to start with, there's hand tools. These are the basic tools of the trade that everybody in this room, I can almost assure you, has touched and used at some point. I'm going to go through these a little bit one at a time. That big old list doesn't really help you without some idea of what we're talking about. The first thing is a well measurement tape. These are not fancy, they're not new, they're not expensive, and everybody can use one. But the backbone of a ton of data in this state was collected using those tools. Maps. And there's a lot of ways that you can have fancy maps and have your own GIS system. You can also use paper maps. As long as you have a map that you know where you're going and you can go there consistently to the same place to collect this information, then you've got your map covered. Field measurement recording. Would anybody like to guess how many measurements I've entered out of somebody's pocket flip notebook? I've entered a lot of measurements in a lot of places out of a pocket notebook. And it was all pretty good data. I've also printed out a whole lot of sheets for somebody to take to a field that had somebody's lat long and maybe a measurement from the last time somebody was there so that they had an idea of how much tape to put in a hole. It's not fancy, doesn't cost a lot of money, but it gets your measurements, it gets your information back. Data storage. A lot of people are just using some very, very basic tools to store their data in, and there's nothing wrong with that. If that's where you are and that's what you need to do, it's something. Get the data, get it into the office, store it in something. A rangefinder is another thing that I have used a lot of, mainly for well spacing and property line spacing. And I have, in fact, used a measurement tape to measure a distance from a fence. You use what you have, right? You also, in this day and age, really, really need a GPS device or an app on your phone. I use one called GPS Essentials. It gets a pretty accurate reading if you can just stand there a minute and get your satellites all lined up and wait on them a minute. And it's a free app, so most people have a smartphone these days, and you can just use that. Rain gauges is another thing. You don't have to track rainfall for a district, but a lot of districts do. It helps you as you're trying to move into the analysis of where's the water being used, why is it being used here, how much water are we using. Knowing how much rain fell naturally is a very good piece of information for a district to have so that they can have the whole picture of, okay, how much water was applied to this crop, how much water was really used here. You can just buy, a regular old rain gauge. The guy that I work with, Ray Brady, has built a whole ton of rain gauges out of PVC pipe and tubing with a little bit of a catchment that stays underground so that the water doesn't evaporate out, and you can just go read them, you go read them once a month and pour it out and measure your milliliters and multiply it by your fancy 0.077697. That takes up space in my head, that exact conversion factor. And you can then have, a network of rain gauges that you don't have to look at every day. You can look at those once a month and have them spread out over your area. There are, of course, fancier ways to do that. We're talking about hand tools. We're going to move on into the power tools. And this is more where I see most districts are landing these days. Most people have kind of moved a little bit past the very basic information to collect and the very basic tools to do it with, and they've tried to take things to the next level. So the first thing I want to talk about is some sort of information collection device or app. When I first started moving past pieces of paper I was printing out for field techs, we had a couple of laptops that went to the field, and I had a database, and I just made them a blank copy of the database with all the headings on it. And they had all of their, their locations and stuff in it, and they could enter that data in the field so that it came back, and I could just append it to the database instead of hand typing it all in. It was a great day when we decided to do that. Hand entry is not fun. It works, but it's not fun. It also introduces some error. The next thing I want you to think about is a database. If you're storing things in a Word document or in Excel, they're not terribly usable. They're not terribly easy to manipulate for you to be able to get to that next level of analysis and trying to figure out what your data's telling you. A lot of my clients use an Access database. This other picture is of, I think, the HAFS database that one of my clients is using. There's a lot of options out there, and there's a lot of people that are realizing that this tool is needed in the groundwater district world and that are starting to develop tools and cater to this specific need. Several of those guys are out in the foyer right now with their products ready to show you. The next thing is well monitoring equipment. So this is a pretty simple idea, but given the fact that most of the wells we are trying to measure are far spread, has been a little bit slow to implement in some places. For a long time, it had to be close enough to Wi-Fi for you to be able to equip a well and be able to transmit that data out into a cloud or onto the internet somewhere so that that data can be stored somewhere. Now they're using, and have been for several years, using cell phone technology. When that first came out, you had to pay a monthly cell phone bill for every one of these that you put in, and it was a little bit expensive, but I've talked to several guys out there just this last couple of days. Most of those guys have gone to a flat fee per year, where we'll put this on for you, we'll install the equipment, it costs you this much, and all of this information feeds into a central location for you to use. Those can be used on pumping wells, on non-pumping wells. I think one of those is a monitoring well from Doug's district in the Northern Trinity. A couple of those are, I think, maybe some of Well Intel, if you've heard of them. That's a couple of pictures that they had sent me of wells that they had plumbed up. One of those is even a municipal well that's being monitored continually. The kind of information that can give you is a little different than getting an annual or a quarterly measurement from a well and having those information, you know, that's that spaced out. This information, you can have it, you tell it how often you want it to measure. You want a measurement every 15 minutes? Great. And you can track over time, okay, what happens when this well turns on? How much cone of depression, how much decline in that well do we see? What happens when the neighboring well turns on? All sorts of things that it can tell you that are not specifically related to, okay, how much is this well, you know, declined over a year? I had one of these that I watched for a while because it told me when the cold fronts were coming in. I mean, you can see a lot of things in some very close measurement time snaps. The next power tool I'm going to talk about is a GIS mapping system. As Andy said, this is one of my passions. I love GIS mapping systems. I think it's a tool that districts need for a lot of different reasons. You can use that map in your office to visualize what data you have. You can use that map when people come into your office looking for information so that they can see what data you have. You can use it when you're permitting. There's a measuring tool on ArcView is the one I use. It's kind of an industry standard. A measurement tool that tells you, you know, how far distances are if you're looking to do distances for permitting or for anything. You know, how a guy is asking, oh, I need to drill a well out here. How much room do I have? You know, that kind of thing. You can also quickly access your scan documents. I don't know if y'all were in this morning, but Meredith talked about her first job at Post Oak Savannah was scanning in permits. And I have to tell you, I spent most of 2006 scanning in permits and well logs. And then we linked those into our GIS system, and now you just click on one of the green dots, and it pops up every bit of scanned information you have about it. And if you click on it with your other tool, it pops up everything that's in your database about it. And so you have all of that data immediately at your fingertips, and you don't spend all of your time looking for things and trying to put it together. It's all right there. Well, now all of a sudden, you are poised to, A, have people in and out of your office in 15 minutes instead of saying, let me get back to you tomorrow. But you're also poised to be able to utilize that data quickly and efficiently to analyze it. What is this telling us? Maybe I have a whole bunch of dots up there saying, okay, well, the long-term trend of all these wells for the last 60 years is these numbers. Even if you don't have someone like me who can come in and make you a contour map or a 3D map or whatever it is that I can do with it, you can turn those dots different colors and look at them and say, oh, well, red is down and green is up and blue means it's staying the same. It takes some time investment to learn a program like this. It takes some knowledge investment to be able to link it with your database, but it's a powerful, powerful multi-use tool. The other thing that some districts are doing is they have well cameras. And so this helps you help people who, when they come in and they say, oh man, this is not working, my well's not working, something happened. And so you can see the casing on the right, there's a picture there where there's obviously some pretty bad flaking and degradation of that casing, and you can say, oh, well, your casing is filled, you know, this kind of thing. Or your perforations are all clogged up, you need to clean it out. I know some boards that have been hesitant to do this kind of thing. It's kind of getting into the pocket of people who do that for a living. I also know some places where there's nobody that will come do that for you for a living, depending on where you live and how far you are from a major place. And let me tell you, I've lived in some very, very far from a major places in my life. Sometimes the groundwater district can fill a role there of providing some service to their constituents that can help them analyze their own problems. And you can tell it's not a great big, you don't have to have a great big huge setup. I know, again, I'll pick on Doug's district. They have a little setup of that I think runs out of the back of a pickup. So it's not it's somewhat pricey, but it's not a huge, it doesn't take a whole huge, semi-truck or anything to run any of it. Another thing is, rather than having, a homemade rain gauge, not that I can't homemade you a rain gauge, but maybe a weather station is the next thing to consider. The cool thing about some of these weather stations is not only are they tracking your rainfall and wind and air temperature, whatever, all of that. Some of those you can also put in soil moisture sensors and that kind of thing. So if you're in an ag area and you can push out information to your producers that here's what your soil profile looks like, and if they'll use it, if you can get that information out there, and that harkens back to, I'm not going to talk about PR and education, but these things all go together. Maybe it's right now. Maybe it's September 1st, and they're trying to decide, do I need one more round or two more rounds on this pivot? And if they don't have that information, they're going to think, yeah, I bet it's better safe than sorry. I better put another little bit of water out. Maybe if they have this information, and the information is the soil profile is full, maybe they can then be assured they don't need that extra round or two of water. There are several people you can cooperate with. I know Tex Mesonet, I think you can contact somebody at TWDB that will cooperate with you on putting a station in. West Texas Mesonet, they're through Texas Tech, and I think they're still putting stations out and are cooperating with people. It's a good thing to look into, and it's something that you could, again, looking at that dual look, not only does it get you good information, it gets you some good PR out there, it gets you some good public face, some of that kind of thing. Okay, ultrasonic flow meters. I want to say, nowhere in this presentation am I talking about installed flow meters. I have a lot of opinions about which ones are good, but that's a policy decision. And so if the policy decision is made that you need those, you can do a little research and figure out which ones you can recommend or require. This is an ultrasonic flow meter. This is just a little tool that you strap on around the outside of a pipe to help producers know how much they're producing. You're just doing a test for them. This is a Panametrics version. It's about $7,000. It's pretty easy to use. I will say that it requires, or at least always did when I was using those, some lube to go under the sensors, and people will look at you funny when you go to Sam's and buy a case of KY, okay? But it's worth it. It's a cool tool. And I have personally done this for a producer who had 7 wells going into a pivot system. The first 5 wells were producing a little more than he thought. And he said, man, I know I have this nozzle for this much. I know how much water's coming in here. How do we already have more water measured in these pipes than I know is going through my pivot system? And I was like, I don't know. Are you losing water somewhere? So we really started thinking. We move on to the next well. I put it on, and the meter starts telling me positive 10, negative 10, positive 10, negative 10. So that water wasn't, that particular well was not strong enough to really even get any water downstream. It was just kind of sitting there. And I thought, oh, well, this one is not contributing any more to your system, so maybe this is part of the issue. And no, he says, I know how much is going out there. I know what's going on. You already told me more water than I'm getting out of my pivot. So, okay, well, let's go to the last well. What does that last well say? Negative 40, negative 60, negative 30, negative 40, negative 30, negative 50. He's pumping water down one of his wells. He wouldn't have known that. So now we have several issues there, no black flow valve and, some issues that needed to be fixed. But this is the kind of thing that is a good tool for a district to have to help producers solve these kinds of issues and to keep them from, they're wasting energy, they're wasting water, none of that's good. You can solve some problems with that, and $7,000 is kind of pricey for one piece of equipment, but it lasts a long time. It's not difficult to use. Maybe that's something you want to consider. Okay, water quality equipment. I'm not a lawyer. I do not play one on television. I'm not even not your lawyer. I'm no kind of lawyer. We don't have water quality authority as groundwater districts. However, even in the absence of any authority, sometimes a little information goes a long way. A lot of our districts do some field level water quality testing. Some of them only do it by requests. Some of them have a specified number of wells they go out and, a certain time of year every year do these certain things. If nothing else, it gives you some information that you can A, show your producers, show your constituents, and B, if you do start seeing a problem, oh gosh, the salinity is spiked here, what's going on? You can report that to somebody, TCEQ, Railroad Commission, who, whatever the issue is, you maybe can get a little bit of a head start on detecting something, and maybe you have a little bit of background level testing that that it used to not be this way and now it's this way. Now we have a change, we have an issue. Some people have nothing but the hand tools over on the left there that you go out in the field and do a couple of little tests. Some people have a whole little lab in their office. I don't know where, you have to think about what's your money and what's your motivation, but maybe water quality is something you want to look into. Okay, spring flow measurement. I'm from the Panhandle. And it may surprise you to know that my internship project was to design a spring flow measurement whole program for the Panhandle of Texas for one little stream. Didn't think we had those up there, did you? We do. The thing that this plays into is, maybe you have a DFC that's about protecting spring flow. Maybe you just want to make sure you're preserving some spring flow. Maybe you have some places that are going into production that are near some environmentally sensitive areas, and you want to be able to at least track what's going on. There are some small, inexpensive tools to get that done. There's a little weir there on the left that shows you one way to do it. There's a little stick probe measurement that the guy on the right's using. They're not hard, they're not difficult, they're not expensive. It does provide you some information. It does get you to where you can at least have a handle on tracking some data for the groundwater surface water interaction that may be occurring. The next thing is well logging equipment. Not too many districts have this. I know a couple that do, and it's basically a way, usually before equipment is installed in a well, before casing's even put in, you run the equipment down the hole, it sends out some signals, and the way that they bounce back can tell you some things like how porous the material is. Maybe you can tell whether it's sands or clays or shells or something like that. If there's any water in it, there's even, I was talking to a guy out here, and he says he can tell you what the TDS of the water is in that area with a downhole equipment like this. Again, this may be getting into somebody's pocket. Your district, your board is going to have to consider that when they decide whether they want to do that or not. But in some places, it's not very readily available. And I know, again, Doug's district there at Northern Trinity, they have this set up out of the back of a pickup, and they're trying to log most wells as they're drilled before they put casing in any of them, just to have that information collected. All right, so let's talk about the automated factory, guys. If you can dream it, they can do it. I'm just going to show you a couple of screenshots because I could spend 2 days talking to you about the things that can be done. This is, let me see, which one is this one? That is going to be the Hydros database system by Collier. This is for Amber at Sandyland, and she can just click on it and it tells her how many of her wells are in which category. It does a little bit of simple display of what her data is. I want you to think about this as not analysis. This is just display. This is showing you what your data looks like. Instead of you having to scroll through, 72 pages of line data, this is a display of what that data is. We're just looking at what do you have. So, of course, she has a lot of irrigation wells and not very many of the other ones. That may be different in your area, but it does give you a very quick glance of what do I have in my database. This is also out of her database, and depending on where she is and what she's doing, it'll kind of auto-generate her a little map of her area that she's working in. And that's kind of what some of her back end of this looks like. And I take that back. Hers is with half. Hers is with half consulting. This is the Hydros database, the back end of the Hydros database. And some of the things you can track, whether you're tracking production, water levels, water quality, whatever it is you're tracking, whatever you're measuring, a database is where it goes. And their stuff does some really cool things too. Flags you when you're missing some permits or missing applications or anything like that. It'll also auto-generate maps, and it'll auto-generate buffers or whatever it is you're looking for. Again, if you can think it up, they can come up with a database tool for you to use, and they can integrate all of your information into a whole integrated system. Some of those, if I am given to understand correctly, can even do some things like make an estimate of if you put a well in that spot, how much drawdown would it, how much might it produce and how much drawdown might happen with it. The thing that I want to leave you with is, who is your builder? That flathead screwdriver and that Phillips screw are not going to get along just real well. And you guys have probably seen this before, but the nexus of getting anything done anywhere, anytime, ever comes down to quality, cost, and time, and you cannot have all three of those. You can have it cheap, you can have it good, but if you want it cheap and good, it's not going to come fast. If you want it cheap and fast, it's not going to be good. You can pick 2 out of the 3, but you just almost never get 3 out of the 3. So it behooves your board to think ahead. Where are we going? When do we need to get there? And who's gonna do it? Some of us have specialized tools. And you need to think about your district is different than anybody else's district. I can say that to every one of you in the room. That is the beauty of a groundwater conservation district in Texas. You're all addressing your local issues with your local people. Can you hire somebody in-house that can manage a database? Can you hire somebody in-house that can analyze your data to tell you what that data that you collected and stored and done all these things with is telling you? If you're gonna hire it out instead of hire somebody in-house, how far can you afford to go with them? How much money do you have to devote to these resources? What is the actual answer you need? If you go to somebody and just say, oh, what can you do for me? Let me tell you, I can give you some answers on that. I can do all kinds of things for you. What can you afford? What is your goal? Where are you trying to get? And that always comes back to, what does your management plan say you're doing? What does your DFC say you're trying to achieve? That's all I've got for you today, guys. Is there any questions?
I had a question on the well camera. How much do those things cost?
I don't really know. It's probably been 10 or 15 years since I priced one, and I want to say it was $10,000 or $15,000 when I looked at it. And it also depends on, depending on how deep your wells are, you pay per foot on the cable. So you have to buy the head, and it's got the camera that goes down, and then one that's on the side that you can kind of rotate around, and then you have to pay for all of that cable with all of the electronics in it also. Then you have to have a laptop that kind of feeds it all back into also. So there's kind of several parts that you have to price individually.
Do we have any questions for Amy?
I just want to point out that there have been several instances where districts have worked money together to buy a downhole camera so that they can use it intermittently.
That's what we do at Brush Country in Duval County and
Yeah.
our district have been talking about.
I'm seeing more and more of that on several things. We're going together to hire a hydrologist or a geologist to do a project over a couple of counties, going together like the guys south of Lubbock that all go together and have one education person. Cooperation is a beautiful thing, guys. I know they hired USGS to do that whole big database thing south of Lubbock and did 3 counties there. So, anything else? I appreciate y'all for having me.
Let's give Amy a round.